This is a group one presentation for machine learning. These are the group members, and here there is a task in which we were working for, which is random forest algorithm. So we started for the introduction by introducing where in machine learning the algorithm are used to help computer making decision or prediction from data. You give the data to the machine, and then it can to the computer, and then it can make a decision or prediction. So here down there is the meaning of a random forest. The random forest algorithm works by creating many decision trees, each containing a random samples of the data. You take the data and give to one tree, and there you have so many trees, and then each tree has to make its prediction based on the data which is given. And then this random forest will combine all the results from those trees and make an average or regression. We have here an example. If we want to predict whether it will float or not, we take so many trees. Each tree in the forest makes its prediction. After taking all predictions of the trees, we can decide if the fruit will occur or when it will not occur. So if the final answer, if we predict many trees predict that there is a fruit, which means the solution or the conclusion will be said as there will be the fruit. We have here the step by step to what the random forest work as it takes the algorithm of the data sets and create many random samples from it. For each sample, build a decision tree using random features. For each tree, make its own prediction. As I said above, each tree has its data set and it will take the decision due to the samples or the data that have been given. Then finally, the random forest then combine all the results. Then classification or taking the majority of the votes. For the regression, it takes the average to see the conclusion, to see what will be the result. This combination of many trees gives more stable and accurate result than a single tree. It is good, it is the best to use more trees because you get the accurate result than using a single tree. We have here the flow chart. We start giving the data to we select a random subset of data and give those data to each tree. Each tree builds the decision tree, which means that each tree make a decision. After making a decision, we predict for the result from each tree. Then we aggregate predictions. Then we get the output of those predictions which were sampled and combined together. And we come to the end. Here there is a flow chart which shows that we have more than one tree. There is a three trees there. Each tree will make its prediction. And then we will be averaging those predictions for getting a regression to get the final result or final value from those trees to make the prediction of all trees. Here there is the key concept to know. What you have to come up with a random regression. Here we have a decision tree, which has the meaning of model that splits data into small groups to make a prediction. It splits those data or in different groups or trees so that you can make predictions. Ensemble learning, combining multiple models to improve accuracy. When you have the result from different groups, you get the result which is accurate because those combinations provide the accurate result. We have bootstrap aggregating for training trees random to reduce overfitting here when model runs the training data to where and will perform poorly on new data. The features important, the measure of how much each feature contributes to the final prediction. You see, when you have different trees, you will get the result from each tree, and you can measure how each tree contributes to the result that you got. The advantages of random forest, it provides high prediction accuracy, work for both classification and regression problem, reduce risk of overfittings, and can handle this data set effectively. Which means that due to taking those that now data sets and provide a single output from different trees, it provides the prediction which is accurate. Identify which input features are most important. There is some disadvantages here because it can take longer to train each tree. Because to train each tree and then come up with the result from the tree. I use more memory because of many trees. Harder to interpret result compared to the single decision tree. If you have a single tree, the result that you get is also the final result. But for this one, you train many trees and you will compare those results from each tree to be getting with a single decision. That is why it is harder to interpret with the result. We have an application in weather environment to see with the rain will be raining in the health care for the diagnosis, to take some symptoms from the patient in the finance and etc. The importance of random forest. A random forest is important because it combines strains of many decision trees, resulting in higher accuracy and better generalization. It can work with both numeric and categorical data, handle missing values, because all the missing values, it can take them because it provides the result from many different groups and prevent overfitting through random sampling. This makes it suitable for solving complexity involving problems in many fields. As a conclusion, the random forest algorithm is one of the most reliable and flexible machine learning models by combining multiple decision trees and provide a stronger performance in both classification and regression tasks. This helps data scientists and engineers to accurate prediction in the area as we highlighted above: healthcare, finance, weather forecasting as the application. This can be used for. Thank you for your kind attention and thank you for your understanding on this. And also, as a group, we thank you.
Thank you.